On October 29, 2025, something unprecedented was scheduled to happen. 3I, Atlas, the third confirmed interstellar visitor in human history, would reach perihelion, its closest point to the Sun. For astronomers, this is the moment of truth, the point of maximum thermal stress, where an object reveals its deepest secrets, blasting gas and dust into space as its surface ices sublimate under the intense solar radiation. It is the moment we learn what something is truly made of. There was only one problem. On October 29, 2025, Earth was on the exact opposite side of the Sun. 3I, Atlas, reached its most critical, most revealing moment while completely hidden from every telescope on our planet. Not partially obscured, completely invisible. A 3-week total observational blackout, precisely when we needed to see it most. Was this a coincidence, an orbital fluke, or something else? This event is the central mystery of 3I, Atlas. But it is not the only one. This object, since its discovery, has presented a cascade of statistical impossibilities. A mass calculated at 33 billion tons, making it thousands of times heavier than Oumuamua or Borisov. A trajectory so perfectly aligned with our solar system's plane that the odds of it happening by chance are less than 1 in 500. It emitted chemicals never before seen in nature, compounds associated only with advanced industrial manufacturing. It passed improbably close to Mars, then Venus, then Jupiter, a celestial grand tour with a 1 in 20,000 probability. The scientific consensus is clear. 3I, Atlas, is a comet, a very large, very strange, natural comet. But a vocal minority, led by figures like Harvard's Avi Loeb, suggest another possibility. They assign a 30 to 40% probability that this object does not have a fully natural origin. They ask if the 3-week blackout wasn't a coincidence, but a convenience, the perfect window to perform a course correction, an engine burn, while completely hidden from prying eyes. This is not another fringe theory video. This is a definitive deep dive. In this investigation, we will separate scientific fact from speculative hypothesis. We will examine the hard data from NASA, the James Webb Space Telescope, and the Very Large Telescope, and we will weigh it against the persistent, unsettling questions that remain. Chapter 1. The Factual File. Before we entertain the hypotheses, before we discuss percentages and probabilities, and before we ask what might have happened during the blackout, we must first establish what did happen. Science operates on a baseline of verifiable, peer-reviewed data. To understand 3I, Atlas, we must first build the factual file, item by item. The story of this object begins not in the darkness of interstellar space, but in the digital systems of a telescope array designed for a very different purpose. The Atlas system, short for Asteroid Terrestrial Impact Last Alert System, is our planetary tripwire. Its robotic telescopes, scattered across the globe, scan the entire observable sky every 24 hours. Their mission is not to find aliens, but to find city killers, asteroids, on a collision course with Earth, giving us just enough warning to, perhaps, do something about it. On a routine scan in late 2024, the system flagged a new object. To the automated systems, it was just another faint point of light moving against the background of fixed stars. It was given a routine designation. But when human astronomers ran the preliminary orbital calculations, the numbers didn't make sense. This is the first and most important fact: the trajectory. In our solar system, every object is bound by the Sun's gravity. Planets, comets, asteroids, they all follow elliptical paths. An ellipse is a closed loop. What goes out must eventually come back in, even if that loop takes thousands of years. This relationship is measured by a number called orbital eccentricity. An eccentricity of 0 is a perfect circle, like Earth's orbit almost. An eccentricity between 0 and 1 is an ellipse, like Halley's Comet. The new object's eccentricity wasn't 0. It wasn't 0.9. The value was calculated to be approximately 3.4. An eccentricity greater than 1 is not an ellipse. It is a hyperbola. It is not a closed loop. It is an open-ended path. It means the object is moving so fast that the sun's gravity cannot capture it. It is not in orbit around our sun. It is simply passing through. This was not speculation. This was not a theory. It was a mathematical certainty. The object had come from interstellar space. This elevated it from a routine detection to a global astronomical event. It was designated 3I, Atlas. 3I meaning the third confirmed interstellar object, following 1I, Oumuamua, in 2017, and 2I, Borisov, in 2019. And immediately, comparisons began. Oumuamua was a mystery. Small, fast, tumbling, and apparently inert, more like a rocky asteroid than a comet. 2I, Borisov was comfortingly familiar. A large comet that behaved exactly as our models predicted, releasing gas and dust just as our own solar system's comets do. 3I, Atlas, we would soon learn, was not like either of them. It was something new. As its path was modeled, a second critical fact emerged. Its trajectory was bringing it remarkably close to Mars. On October 3, 2025, 3I, Atlas, was projected to pass within 0.19 astronomical units of the red planet, roughly 18 million miles. This was an extraordinary scientific opportunity. For the first time, we would have a spacecraft in the vicinity of an interstellar visitor. That spacecraft was the Mars Reconnaissance Orbiter, or MRO. MRO was not designed for astronomy. It was designed to look down, not up. Its primary instrument, the High-Resolution Imaging Science Experiment, or HiRISE camera, is a masterpiece of engineering, built to photograph the Martian surface from orbit with enough resolution to distinguish individual boulders. On October 3, NASA engineers performed a complex maneuver. They turned the multi-billion-dollar orbiter around, pointing its incredibly powerful, narrow-field camera away from Mars and into the blackness of space to intercept a faint, fast-moving target tens of millions of miles away. It was one of the most difficult imaging attempts ever conducted by the mission. And it worked. The images, when they were finally processed and released, became the official public face of 3I Atlas. They showed a comet. The nucleus itself was too small to be resolved, appearing as a bright concentration of light, but surrounding it was a vast, diffuse, teardrop-shaped coma of gas and dust. Exactly what one would expect from an active comet approaching the sun. NASA's official statement was precise and unequivocal. The images showed no features inconsistent with natural cometary structure. There were no geometric shapes, no anomalous lights, no visible propulsion. This was a crucial data point. From the outside, at least from 18 million miles away, 3I, Atlas, looked natural. This observation aligned with data from the Hubble Space Telescope, captured months earlier on July 21. Those images had caused a brief stir by showing a faint extension of light pointing toward the sun rather than away from it, a feature that seems to defy physics. But scientists quickly identified this as a known imaging artifact. When photographing a fast-moving object over a long exposure, the object's own motion can create a blur in the direction of travel. Since Atlas was moving toward the sun at the time, the artifact pointed toward the sun. It was not a physical jet. The consensus was, and remains, that this was a technical glitch, not an anomaly. The MRO and Hubble images provided the what. The next step was to determine its what, as in, what is it made of? For this, astronomers turned not to images, but to spectrographs. These instruments are the true detectives of astronomy. They break light apart into its fundamental rainbow of colors, and within that spectrum, they read the chemical barcodes of the elements and molecules present. The most powerful spectrographs in the world, attached to the James Webb Space Telescope, JWST, and the European Southern Observatory's Very Large Telescope, VLT, in Chile, were pointed at 3I, Atlas. What they found is perhaps the most important and most confusing factual data we have. First, the JWST confirmed that 3I, Atlas, was dominated by carbon dioxide. It was releasing CO2 gas at a rate roughly 8 times higher than water. This is, by itself, highly unusual. The vast majority of comets in our solar system are water-ice dominated. Their activity is driven by the sublimation of H2O. A CO2-dominated comet is rare, suggesting it formed in an extraordinarily cold region of its parent star system, much farther out than where our own comets were born, in a place where CO2 ice is more stable than water ice. Alongside the CO2, the VLT detected a suite of other, more familiar, cometary compounds: water, carbon monoxide, carbonyl sulfide, and cyanide. These findings were, in a sense, reassuring. This was the chemical signature of a comet, albeit a very cold one. Then came the metals. In late August 2025, the Very Large Telescope detected the faint but unmistakable signature of atomic nickel vapor in the comet's coma, being released at a rate of approximately 4.6 grams per second. This, too, was not entirely unprecedented. Nickel had been detected in solar system comets before, and was even found in 2I Borisov. It's believed to originate from metal-bearing minerals on the comet's surface that break down under solar heat. But the discovery came with a profound, record-scratching omission. Where was the iron? In astrophysics, nickel and iron are cosmic partners. They are forged together in the hearts of dying supernovae. They travel together through interstellar space. They condense into primitive solar system materials together. In every documented comet where nickel has been found, iron has been found right alongside it, in roughly equal proportions. It is one of the most consistent chemical relationships in planet formation. The VLT spectrum for 3I Atlas was clear. There was a spike for nickel, but the corresponding spike for iron was absent, vanished. This was not a theory. This was a measurement. It was like finding a plume of smoke with no heat. It was a chemical fingerprint that violated every established model of cometary chemistry we have. Scientists scrambled for explanations. Perhaps the iron was present, but locked in compounds that didn't break down as easily. Perhaps the temperature and radiation environment of this specific comet's coma was hiding the iron signature. But the simplest explanation, the one staring back from the data, was that this object contained nickel, but for some reason was almost completely devoid of iron. So let us summarize the factual file as we head into the gray zone. Fact: 3I Atlas is definitively interstellar, confirmed by its hyperbolic orbit. Fact: when imaged by MRO and Hubble, it presented all the visual characteristics of a natural, active comet. Fact: its composition is broadly cometary, dominated by carbon dioxide and water ice, suggesting a very cold origin. And fact: it contains a chemical signature nickel without iron that has no known precedent in nature and directly contradicts our understanding of how star systems form. This is the baseline. This is the data, a set of facts that seem to contradict each other. An object that looks like a comet is made mostly of comet, but possesses a chemical signature that a comet should not have. It is this conflict in the data itself, this tension between the normal and the impossible, that opens the door to the anomalies, the statistical improbabilities, and the unsettling hypotheses that would follow. The factual file was closed, but the real investigation was just beginning. Chapter 2. The Gray Zone of Statistical Anomalies. The factual file for 3I, Atlas, as presented, seems to contain a deep, fundamental contradiction. On one hand, visual observations from MRO and Hubble show an object that, for all intents and purposes, looks and acts exactly like a natural comet. On the other hand, spectroscopic data from the VLT reveals a chemical fingerprint that should not exist in nature. This is the nature of a true anomaly. It's not a single, isolated problem, but a cluster of data points that refuse to align. To understand the gray zone, we must move beyond the simple facts and into the staggering improbabilities they create. We begin with the most basic characteristic of all, its mass. When comets approach the Sun, they are not just passive objects being pulled by gravity, they are active, dynamic bodies. The ice on their surface turns directly from solid to gas, a process called sublimation. This gas jets off into space, and just like a tiny rocket engine, it pushes the comet. This push is called non-gravitational acceleration, or NGA. Astronomers are experts at measuring this. We track a comet's position over time and compare where it is to where pure gravity says it should be. If it's ahead of schedule, behind schedule, or slightly off to the side, we know that outgassing is pushing it around. We can detect this force with extraordinary precision. The fact is, 3I, Atlas, was clearly, unambiguously outgassing. The MRO images showed a massive coma. The JWST measured hundreds of kilograms of CO2 and other gases streaming away from it every second. The object was, by definition, an active comet. Therefore, it should have been experiencing massive, easily detectable, non-gravitational acceleration. But it wasn't. Its trajectory matched a purely gravitational path, to within extraordinarily tight margins. The upper limit on its NGA was less than 15 meters per day squared. For an object this active, this reading was vanishingly small. It didn't make sense. An object cannot be firing its engines and not accelerating. There is only one explanation consistent with both observations, that it is outgassing and that it is not accelerating measurably. The object must be so incomprehensibly massive that the force of its own jets is meaningless. It's like trying to push an aircraft carrier with a garden hose. The force from the hose is real, but the mass of the ship is so large that the acceleration is undetectable. Astronomers did the math. Given the observed gas loss rate, measured by JWST, and the absence of detectable acceleration, what is the minimum mass this object must have? The answer came back: 33 billion tons. This number is difficult to contextualize. It is 3 to 5 orders of magnitude, that is, a factor of 1,000 to 100,000 times more massive than either 1I, Oumuamua, or 2I Borisov. Assuming a standard cometary density, this implies a minimum diameter of over 5 kilometers, and possibly much, much more. And this creates the first, and perhaps largest, statistical problem. Objects in space, from pebbles to planets, follow what is known as a power law distribution. This is a fundamental pattern in nature. For every one large object, there are exponentially more smaller ones. For every one 10-kilometer rock, there should be hundreds of 1-kilometer rocks, thousands of 100-meter rocks, and millions of 10-meter rocks. The numbers explode as you go smaller. The universe simply doesn't make as many mountains as it makes pebbles. Based on every model of planet formation we have, astronomers can calculate how often we should expect to see interstellar objects of various sizes pass through our solar system. For something in the 5 to 10 kilometer range, the expected rate is approximately once per 1,000 years. Perhaps once per several thousand years, we have been systematically searching for interstellar objects for roughly 1 decade. In that single decade of looking, we have found 3. and the third one just happens to be a member of the rarest size class imaginable, an object so large our models predicted we shouldn't see one for another millennium. This is what scientists like Avi Loeb call the mass budget problem. There simply isn't enough rocky debris floating around in interstellar space, at least according to our models, for us to be finding a 3 billion-ton object this quickly. This is the gray zone of the mass anomaly. Either our fundamental understanding of planet formation and the distribution of matter in the galaxy is wrong, or this object is not a random piece of ejected planetary material. But the mass was only the beginning. The second anomaly is, in some ways, even more improbable: its trajectory. As we've established, interstellar objects should come from random directions, at random angles. Our solar system is relatively flat. The 8 planets orbit the Sun in roughly the same plane, a disk called the ecliptic. Think of it as a giant dinner plate, a geometric memory of the spinning cloud of gas and dust from which we were born. An interstellar visitor shouldn't care about our ecliptic plane. It should, by all statistical logic, arrive from a random angle, from above the plate or below it. The probability of any random object happening to align closely with our specific, thin, orbital plane is tiny, approximately 1 in 500, or 0.2%. 3I, Atlas, arrived with an orbital inclination of 175 degrees. This means it was moving retrograde opposite to the planets, but tilted only 5 degrees from the ecliptic plane itself, nearly flat, nearly perfectly aligned. A 1 in 500 chance. Unlikely, but not impossible. A statistical fluke. But the trajectory analysis doesn't stop there. 3I Atlas didn't just pass through our dinner plate. Its path brought it remarkably close to 3 of the plates on it: Mars, Venus, and Jupiter. Consider what this requires. These planets are not stationary. They are moving targets, all at different distances, all moving at different speeds. Mars takes 687 days to orbit the Sun. Venus takes 225 days. Jupiter takes 12 years. For an interstellar object to pass near all 3 during a single flyby, the timing has to be perfect, aligning across multiple independent orbital periods. On October 3, 2025, it passed within 18 million miles of Mars. On November 3, 2025, it would pass within 60 million miles of Venus. On March 16, 2026, it is projected to pass within 33 million miles of Jupiter. This is a celestial grand tour. Avi Loeb and his colleagues calculated the combined probability of an object already on an improbable 1 in 500 ecliptic-aligned path, also happening to thread the needle this closely to 3 major planets. The answer: approximately 1 in 20,000, or 0.05%. This is the gray zone of the trajectory anomaly. Loeb uses a gambling analogy. If you watch someone roll double sixes once, it's a fluke. If you watch them do it 10 times in a row, the odds are astronomical, but not 0. You don't know the dice are loaded, but you would be a fool not to examine them. The trajectory of 3I, Atlas, is that sequence of double sixes, a 1 in 500 alignment compounded by a 1 in 20,000 series of planetary encounters. At what point does coincidence become a pattern? At what point do we stop calling it chance and start calling it significant? This question, this deep statistical imbalance, is what makes the third anomaly so profoundly unsettling. The mass is improbable, the trajectory is improbable, but the chemistry is where the gray zone darkens, moving from improbable to, perhaps, impossible. Let's revisit the chemical facts, but this time with a more precise and far more disturbing piece of data that came from the VLT analysis data that almost nobody outside the astronomical community is discussing. The VLT did not just detect atomic nickel, That was the simplified finding. The actual spectral signature was for a specific compound, nickel tetracarbonyl. What is nickel tetracarbonyl? It is a volatile compound, a nickel atom bound to 4 carbon monoxide molecules, and it has 2 properties that are critical to this investigation. First, it is highly unstable. Solar radiation and the vacuum of space should break it down almost immediately. Finding it in a comet's coma is like finding a snowflake in a furnace. Second, and this is the crux of the entire anomaly, nickel tetracarbonyl has never been observed in nature. Not once. It is not found in meteorites. It is not found in stellar nebulae. It does not exist in any known natural environment. It is, however, a well-known compound on Earth. It is the cornerstone of the Mond process, an industrial manufacturing technique developed in 1890 to refine pure nickel from ore. It is, exclusively, an industrial byproduct. The Very Large Telescope confirmed it, 4 grams per second, and, as we noted in Chapter 1, with no associated iron present, a finding that already violated known physics. But this new data was 1,000 times more shocking. It wasn't just nickel without iron, it was industrial nickel. This is the gray zone of the chemical anomaly. It forces a question that science is deeply uncomfortable asking. Is it more likely that 3I, Atlas, represents a completely new, unknown, and almost magical form of natural cometary chemistry that, by pure coincidence, mimics an advanced 20th century industrial process? Or is it more likely that the simplest explanation is the correct one, that we are observing an advanced industrial process? This is the cluster, the pattern. It is not just the mass. It is not just the trajectory. It is not just the chemistry. It is the fact that all 3 statistical impossibilities are present in the same object. An object with a 1 in 1,000 year mass on a 1 in 500 ecliptic aligned trajectory that executes a 1 in 20,000 planetary grand tour, all while emitting an industrial chemical compound that has never been seen in nature. This is the gray zone. This is the point where the official consensus explanation of it's just a very large, weird comet begins to feel intellectually insufficient. It is this cascade of compound improbabilities that forced a very small, very serious group of scientists to ask the one question they are trained to avoid. What if it's not a comet at all? Chapter 3. The Artificial Origin Hypothesis. The question posed at the end of Chapter 2, what if it's not a comet at all, is not one that science asks lightly. It borders on taboo. It invites ridicule and threatens careers. The default and safest explanation for any object in space is that it is natural. Science operates on Occam's razor. The simplest explanation is usually the correct one. But what happens when the simplest explanation, that 3I, Atlas, is a natural comet, requires us to accept a chain of statistical miracles? A 1 in 1,000 year mass on a 1 in 500 trajectory, executing a 1 in 20,000 planetary flyby, all while composed of chemicals that defy known physics. At a certain point, the simplest explanation begins to look extraordinarily complex. This is the ground upon which Professor Avi Loeb of Harvard University makes his stand. Loeb, the former chair of Harvard's astronomy department, is the same scientist who famously challenged the consensus over Oumuamua, and he is the most prominent and most credentialed voice arguing that 3I, Atlas, warrants a more profound investigation. Based on the aggregation of anomalies we explored in Chapter 2, Loeb has publicly assigned a 30 to 40% probability that this object does not have a fully natural origin. This is not a guess. It is not a fringe belief. It is a statistical assessment. It is a way of saying that the probability of all these natural anomalies coincidentally clustering together in one object may be lower than the probability of a single alternate explanation. that they are not coincidences at all, but evidence of intentional design. This is the artificial origin hypothesis, and when you apply it, the entire narrative of 3I Atlas changes. The data points that were baffling contradictions suddenly and chillingly snap into alignment. Let us re-examine the three great anomalies from Chapter 2, not as a series of natural flukes, but as a series of technological solutions. We begin with the primary problem, the mass. The fact is, 3I Atlas is outgassing. We see the coma, but not accelerating. We don't see NGA. The consensus explanation, as we've noted, is that the object is simply too massive to be pushed by its own jets. The minimum mass required is 33 billion tons. The problem with that explanation is that a 33 billion ton solid object, a 5 to 10 kilometers mountain, is a 1 in 1,000 year rarity. We found it in a decade. The artificial origin hypothesis offers a different and far more elegant solution. What if the mass isn't derived from bulk, but from structure? If you were an advanced civilization, designing a vehicle to travel between star systems for millions of years, you would not build it as a solid 5-kilometer chunk of rock. That would be impossibly heavy and breathtakingly inefficient, requiring unimaginable energy to accelerate and decelerate. You would build it the same way humans build every long-distance vehicle, from ocean liners to spacecraft. You would build a shell, a thin structural framework with a vast, empty interior volume. You would maximize strength and minimize mass through geometry. Let's do that math. A hollow sphere, 10 kilometers in diameter, with structural walls a few hundred meters thick, could easily weigh 33 billion tons. This hollow shell hypothesis solves both mass problems at once. First, it provides the 33 billion tons of mass necessary to resist the push from surface outgassing, perfectly explaining the absence of non-gravitational acceleration. Second, it solves the 1 in 1,000 year rarity problem. We're no longer looking for a solid mountain of debris. We're looking at a vehicle. This single hypothesis resolves the central contradiction of 3I Atlas. It has the inertia of an aircraft carrier, but it doesn't have to be a solid block of iron. It can be an aircraft carrier. But this raises an immediate and powerful counter-argument. If it is a vehicle, a hollow shell, why did it look exactly like a natural comet in the MRO and Hubble images? Why the teardrop-shaped coma? Why the gas and dust? This brings us to the second pillar of the artificial origin hypothesis, an idea Loeb has called frost on the windshield. The hypothesis argues that any object, natural or artificial, traveling through the cold vacuum of interstellar space for millions of years will accumulate debris. It is an unavoidable consequence of its journey. Cosmic dust, micrometeorites, ice particles, and volatile compounds like frozen carbon dioxide would constantly pelt its surface. Over eons, this material would build up, layer upon layer, freezing to the object's hull. It would create a mantle, or a crust, of natural, cometary material, completely encasing whatever lies beneath. By the time this object arrived in our solar system, it would be perfectly, and perhaps intentionally, cloaked. It would be a technological object, wearing a comet costume forged from the interstellar medium itself. And what would happen when this cloaked object approached our sun? Its surface, that outer layer of accumulated frost, would respond to solar heating exactly as a natural comet's surface would. The ices would sublimate. The dust would be released. It would create a diffuse coma. It would produce carbon dioxide and water vapor. From millions of miles away, our telescopes would see a comet. This hypothesis elegantly explains the contradiction between the MRO's natural images and the object's unnatural underlying mass and trajectory. We weren't observing the object itself. We were observing its shield. This isn't even deep speculation. It is a logical certainty. A technological object traveling for eons would be coated in cometary material. It would be visually indistinguishable from a natural comet until it decided to reveal itself. And this leads us to the third, and most profound, pillar of the hypothesis: the timing, the blackout. Let's return to the central mystery of this entire event. October 29th, 2025. Perihelion. The moment of maximum solar radiation. The moment 3I, Atlas was completely, totally hidden behind the Sun for 3 critical weeks. We are told this was a coincidence, a random alignment of orbital mechanics. The probability of this happening by chance, depending on the orbital geometry, ranges from 1 in 20 to 1 in 30. Unlikely, but not impossible. But what if it wasn't a coincidence? What if, in the context of an artificial probe, this wasn't an obstacle to observation, but a requirement for action? Perihelion is a very special moment in orbital mechanics. It is the point where an object is traveling at its absolute maximum velocity, and because of a principle called the Oberth effect, it is the single most fuel-efficient, optimal location to perform a major propulsive maneuver. If you fire your engines with the direction of travel at perihelion, you get a massive boost in speed, using the Sun's gravity to slingshot you into the outer solar system. We do this all the time with our probes. But the principle also works in reverse. If you are an interstellar object on a hyperbolic escape path, and your mission is to stay in the solar system, you must slow down. You must perform a capture burn. And the single most efficient moment to do this is at perihelion. You fire your engines against your direction of travel, a retro burn or reverse Oberth maneuver. The Sun's gravity amplifies the braking effect, slowing you down just enough to change your trajectory from an open-ended hyperbola to a closed-ended ellipse. You would be captured. You would be in orbit. The artificial origin hypothesis makes a chilling proposition. The 3-week perihelion blackout wasn't a fluke. It was a feature. It was the perfect, scheduled window for 3I, Atlas, to perform its capture burn. Using propulsion systems hidden from our view, it could slow itself down, change its orbit, and ensure its permanent place in our solar system, all while Earth's prying eyes were blinded by the Sun. If this hypothesis is true, it means that when 3I, Atlas, re-emerged from behind the Sun in mid-November, it was no longer on its original, calculated escape path. Its trajectory would be subtly, but definitively, different. This framework is powerful because it connects every single anomaly into one logical, intentional narrative. Suddenly, the 1 in 20,000 Grand Tour trajectory, Mars, Venus, Jupiter, no longer looks like a fluke. It looks like a flight plan, a deliberate, pre-calculated mission to survey the most interesting planets in our system. The hollow shell structure is no longer a wild guess. It's the logical design for an interstellar vehicle. The comet cloak is no longer a theory. It's the unavoidable consequence of its journey, a perfect natural camouflage. The perihelion blackout is no longer a coincidence. It's the scheduled, optimal moment for its mission's next phase. And finally, this framework provides the only logical answer to the most baffling fact of all: the chemistry, the nickel tetracarbonyl, the industrial compound that should not exist in nature. In the natural comet model, this fact is an impossibility that must be dismissed or ignored. It requires us to invent new, unknown physics to explain it. In the artificial probe model, it is simply a byproduct. Perhaps the 4.6 grams per second of nickel tetracarbonyl detected alongside the natural CO2 and water was a leak, a faint trace of industrial coolant, or a byproduct of an advanced manufacturing process, or even the signature of an exotic energy source or propulsion system we cannot yet comprehend. It wasn't natural chemistry. It was an engine exhaust. This is the power of the artificial origin hypothesis. It does not require us to believe in a series of cascading statistical miracles. It requires us to believe in only one improbable thing: that another civilization exists, and that they sent a probe. Once you accept that single premise, every piece of data falls into place. The contradictions vanish. The impossible becomes logical. The random flukes become a pattern of intelligent, deliberate, and extraordinarily discrete action. This is the hypothesis that was on the table as 3I Atlas re-emerged from behind the sun. It presented a terrifying, falsifiable prediction. When we looked at the object again in mid-November, its trajectory would be different. It would have slowed down. We were now in a state of observational limbo. We had the facts, we had the anomalies, and we had a hypothesis that explained everything, but one that was so profound, it threatened to rewrite our entire understanding of the universe. The scientific consensus, however, was not ready to be rewritten, and they had their own explanations. Chapter 4. The Rebuttals. The Scientific Consensus. The artificial origin hypothesis is elegant. It is compelling. It takes a box of seemingly random, contradictory data points and, with one key, unlocks a single, coherent narrative. It is a powerful piece of storytelling. But in science, elegance is not enough. As Carl Sagan famously stated, extraordinary claims require extraordinary evidence. The scientific consensus, the collective, peer-reviewed judgment of the overwhelming majority of astronomers, astrophysicists, and planetary scientists, is that 3I Atlas is not a probe, it is a comet. This conclusion is not born from a lack of imagination, or a fear of ridicule, or an institutional conspiracy to hide the truth. It is born from a rigorous application of the same principle that guides all discovery: Occam's razor. The simplest explanation, the one that requires the fewest new or unsupported assumptions, is the one that is most likely to be correct. And the paradox is this: to the scientific consensus, the natural comet explanation is, by far, the simpler one. The artificial origin hypothesis, while seeming to connect the dots, requires one planet-sized assumption at its core: that an advanced, interstellar, technological civilization exists and has sent a probe, and that probe is here now. The natural comet hypothesis requires only that the universe is a bigger, weirder, and more diverse place than our current, very limited models predict. History has shown, time and time again, that this is always a safe bet. Let us, therefore, dismantle the cluster of anomalies, one by one, not with speculation, but with the explanations provided by the scientific consensus. We begin with the primary pillar, the 3 billion-ton mass. The consensus does not dispute the 3 billion-ton number. The math is correct. The aircraft carrier and garden hose analogy that the object is too massive to be pushed by its own outgassing is the accepted explanation. The consensus agrees that 3I Atlas is incomprehensibly massive. The disagreement is with the implication of that mass. The rarity argument states this is a 1 in 1,000 year object, and we found it in a decade. The scientific rebuttal is simple and humbling. This implies our models are wrong. Our 1 in 1,000 year calculation is based on a laughably small, statistically meaningless sample size. Before 3I Atlas, we had 2 confirmed interstellar objects. 2. You cannot build a predictive model of the entire galaxy's population of debris based on 2 data points. It is entirely possible, and in fact probable, that massive 5 to 1 0-kilometer interstellar objects are far more common than we believed. 3I Atlas isn't the anomaly that breaks the model. It is the data point that corrects the model. We didn't find a 1 in 1,000-year object. We simply learned that the odds were never 1 in 1,000 to begin with. Finding a rare object first isn't proof of magic. It's just statistical luck. It's pulling a royal flush on the first hand of a poker game you've ever played. It's weird, it's improbable, but it happens. And it's a far, far simpler explanation than assuming the deck was built by aliens. Next, let us address the trajectory, the 1 in 500 ecliptic alignment, and the 1 in 20,000 grand tour of Mars, Venus, and Jupiter. The consensus explanation for this is, again, statistical, but this time, it's about perspective. A 1 in 20,000 probability sounds impossibly low, but in a galaxy of over 100 billion star systems, each one ejecting billions of comets over eons, a 1 in 20,000 chance is not just possible, it is a mathematical inevitability. Somewhere, sometime, an object will have this exact trajectory. It is cosmic destiny. We just happened to be the civilization that was here, and had telescopes pointed in the right direction at the right time to witness it. This is a classic case of selection bias, or the anthropic principle. We do not see the tens of millions of other interstellar objects on boring trajectories that miss us by billions of miles. We only see and pay attention to the one that threads the needle. We are, in effect, painting a bullseye on ourselves and then expressing shock when something finally hits it. It is not a flight plan. It is a coincidence. A staggering, beautiful, cosmic coincidence. Now, we must tackle the most difficult rebuttal. The chemical anomaly, the nickel tetracarbonyl, the industrial compound that, as Chapter 2 stated, has never been observed in nature. This, right here, is the core of the scientific argument. The phrase "never observed in nature" is an observation about the limits of human experience, not a statement about the limits of the universe. For the last 100 years, our nature has been our solar system. We have studied thousands of comets and asteroids, all born from the same cloud of gas and dust. They all share the same basic chemical inventory. 3I, Atlas, is the first specimen we have ever encountered from a completely different, unknown stellar environment. We have a sample size of 1. We must not, assume that the rules of our backyard apply to the entire galaxy. The consensus hypothesis is not that 3I Atlas is leaking from an engine. It is that 3I Atlas represents an entirely new class of comet, one formed in an environment so alien it forces us to write new chapters in astrochemistry. Imagine a star system extremely rich in carbon monoxide, and perhaps, for reasons we don't understand, also rich in nickel. Imagine it being so cold that chemical processes we've never been able to study or replicate on Earth can occur over millions of years. Is it truly impossible that in such an environment, under such exotic conditions, nickel tetracarbonyl could be formed naturally? The consensus argues that this is far more likely than an alien engine. And what about the missing iron? The consensus suggests that in this unique, ultra-cold environment, the iron was locked up in other, non-volatile compounds. Perhaps it was bound into heavy silicates, rock, while the nickel remained free to bind with the abundant carbon monoxide gas. 3I. Atlas is not an industrial object. It is a chemical Rosetta Stone. It is teaching us that cometary formation is not a single process, but a vast spectrum of possibilities, and we have just been given our first glimpse into that new, exotic chemistry. It's not an engine leak, it's just a different recipe. Finally, we come to the great test of the artificial origin hypothesis, the falsifiable prediction, the claim that the perihelion blackout was a capture burn, and that the object's trajectory would be different when it re-emerged. This was the moment. The hypothesis was on the line. In mid-November, telescopes on Earth reacquired 3I Atlas, as it cleared the sun's glare. The new orbital data began to come in. And what did it show? As of mid-November 2025, preliminary observations, and these are still being refined, a crucial point suggested that its trajectory remained hyperbolic. There was no obvious sign of a massive orbital change, no clear evidence of a capture burn that would have shifted it from an escape path to a bound orbit. It was still on its way out. To the scientific consensus, this was the final, decisive piece of evidence. The object had passed through its moment of maximum opportunity, and it had done nothing. It behaved exactly as a natural object would. The blackout was not a feature. It was a fluke, a simple, unremarkable coincidence of orbital timing. The artificial origin hypothesis, while elegant, had made a prediction, and that prediction, at first glance, did not appear to pass the test. So, where does this leave us? The consensus view is powerful and, in its own way, just as profound. 3I. Atlas is not a messenger. It is not a vehicle. It is a fossil. It is a pristine 3 billion-ton chunk of another solar system, delivered to our doorstep. It is a natural object so extreme in every one of its characteristics, its mass, its path, its chemistry, that it forces us to rewire our fundamental understanding of how star systems form. It is valuable because it is so strange. It is the data point that proves our models are too small, our imagination too limited, and our chemical rules far from universal. The scientific consensus in this case is not the boring explanation. It is the explanation that expands the boundaries of the natural universe, proving it to be more varied, more complex, and more surprising than even our most speculative fictions. This is the consensus. And yet, the book is not entirely closed. The data from the perihelion passage is complex. Orbital mechanics are precise. The phrase "no obvious sign" is not the same as no sign at all. The final, definitive calculations of its trajectory measurements, sensitive enough to detect not a massive capture burn, but perhaps a tiny course correction, are not yet complete. And that leaves one final chapter, the one that deals with the data still to come. Chapter 5. The Unanswered Questions and the December Approach. We stand at an impasse, a perfect, symmetrical, and deeply unsettling stalemate. On one side, we have the natural comet hypothesis. This is the scientific consensus. It is the safe harbor of Occam's razor. It posits that 3I, Atlas, is a fossil from a distant star system, a 3 billion-ton behemoth whose impossible mass, trajectory, and chemistry are not impossible at all, but are simply the first data points in a new, larger model of the universe. In this model, our 1 in 1,000 year rarity is a sampling error. Our 1 in 20,000 trajectory is a statistical inevitability, and the industrial nickel tetracarbonyl is just a new, exotic form of natural chemistry we've never seen before. This hypothesis asks us to believe that our understanding of the universe is incomplete. On the other side, we have the artificial origin hypothesis. This is the elegant, outlier explanation. It posits that 3I, Atlas, is a machine, a hollow-shelled 3 billion-ton probe, cloaked in cometary ice, that arrived on a pre-planned flight path, surveyed our inner planets, and then used the 3-week perihelion blackout to execute a hidden propulsive burn. In this model, the mass is an engineering solution. The trajectory is a flight plan. The chemistry is an engine leak. This hypothesis asks us to believe that our understanding of our place in the universe is incomplete. Chapter 4 presented the consensus rebuttal, and it was powerful. It made a specific, falsifiable claim. If the artificial hypothesis were true, the object's trajectory would have changed after the blackout. Preliminary data in mid-November showed no obvious change. The object still appeared to be on a hyperbolic escape path. The case, it seems, was closed. But this is where the final, most crucial gray zone remains. The analysis of an object's deep space trajectory is not instantaneous. The data gathered in mid-November was preliminary. It was enough to confirm that a massive capture burn, the kind that would move it into a permanent, short-period orbit, did not happen. But what if that was never the goal? The artificial origin hypothesis does not require a full capture. A tiny, efficient course correction at perihelion, a 1% change in velocity, would be all that is needed to slightly alter its path, perhaps to aim it at a specific target in the outer solar system, or to use Jupiter's gravity in March 2026 for a final, massive slingshot. A burn that small, that subtle, would be almost indistinguishable from the noise of natural outgassing in the early data. We would not find it in the preliminary observations. We would only find it by gathering weeks and weeks of high-precision astrometric data, allowing supercomputers to model its new path and compare it to the old one. We would be looking for a tiny, persistent deviation, a residual, a fingerprint. That is why the period now, leading up to the December 15th closest approach, is the most critical of the entire encounter. On December 15th, 2025, 3I Atlas will make its closest pass to Earth at a distance of 1.8 astronomical units, or 170 million miles, for 10 days. From December 10th to December 20th, this object will be in the optimal viewing window for every major observatory on Earth and in space. This is our last chance. This is the 10-day window where we stop speculating and we start answering the final, unanswered questions. Here is what every major telescope, Hubble, the James Webb, the VLT, and others will be looking for. First, and most importantly, the trajectory. The December observations will provide the final, definitive data points needed to calculate its post-perihelion orbit. This data will end the debate. The trajectory will either match a purely gravitational path, influenced only by the Sun, the planets, and its own natural outgassing, or it will not. If the computers detect a residual acceleration, a tiny, unexplained force that cannot be accounted for by natural processes, the artificial hypothesis will no longer be a 30% probability. It will become the leading explanation. Second, the nucleus. At its closest approach, Hubble and the JWST will attempt to resolve the nucleus itself. We will finally see what 33 billion tons looks like. Is it a single, solid 10-kilometer rock? Is it a contact binary, two objects stuck together? Or, in the most profound possibility, will the images reveal any hint of structural regularity, any glint of reflected light that is not from rock or ice? Third, the post-perihelion chemistry. The JWST will take a new spectrum of the gases in its coma. The chemical profile before the blackout was baffling. What is it after? Is the nickel tetracarbonyl signature still there, or did the engine shut down? Did the perihelion burn-off reveal a new underlying layer with a different composition? Fourth, the rotation. We will finally lock down its rotation period. Is it tumbling chaotically, like a natural piece of debris, or is its rotation stable, or perhaps even attitude-controlled, maintaining a specific orientation as it flies? These observations will provide answers. They will not be ambiguous. We are currently in the gap, the brief, tense window between an unexplained event and the arrival of the final data. For 6 months, we have been forced to balance two realities. The first is that 3I Atlas is the strangest, most statistically improbable natural object humanity has ever witnessed. A fossil from another world so alien it rewrites our books on chemistry and planet formation. The second is that it is not. The line between fact and hypothesis, between a cosmic fluke and a deliberate flight plan, has never been thinner. The data from December will not be an interpretation. it will be a verdict. It will tell us whether the path 3I Atlas is currently on, the one bringing it 170 million miles from our home, is a path that was determined by gravity and chance, or one that was determined by choice.